Hello, Chip GT here, and in the last video we put together the meshroom computer and we were working on getting the cabinet ready to go. In this video we're actually going to mount the PC and we're going to run a whole slew of testing to make sure that the cooling solution I came up with works. So without any further delay, let's coin in and push that start button. First, I need to say a very big thank you to all of you who have watched my videos. The Vpin Wizardry channel has reached the milestone of 300 subscribers with over 1,500 watch hours. To celebrate that, Pinball Life has very generously given all of you a promo code of promo10 to use at checkout for 10% off of your next purchase. Pinball Life is home to just about any pinball machine part you can think of for real pinball machines, and it has been a true resource for those of us in the build your own cabinet and virtual pinball community. And they have all kinds of parts and things that you might need for a virtual pinball machine, from glass to plumb bobs and shaker motors and almost everything that I have installed on my back box. This is where I normally go for all of my virtual pinball needs for quality parts at lower prices. And this code is good until 21 September 2023. So be sure to use promo code 10 at checkout for your next purchase. And thank you for watching, subscribing, and sharing these videos with your friends. So what I want to do with the meshroom is I'm going to actually recess it down into the cabinet a little bit. And what we'll do is we'll measure in 1/2 inch all the way around, and we'll draw a box on the inside of the cabinet there, and we'll cut out that inside box. And then using a Dremel tool and a 1/2 inch Dremel bit, we'll Dremel out a 1/2 inch channel that is 1/2 inch tall and 1/2 inch wide all the way around. And then the meshroom should sit right inside of this little lip. So in order to cut this out, the first thing I did was I drilled 4 holes kind of in the middle of each side. And then using a jigsaw, I cut some relief cuts so I could get in there and kind of cut on the inside of the line that I drew and cut out this square. When using a Dremel tool with a routing bit in there, I wanted to measure the outer diameter of the bevel that I have here, and it came out to be about 28 millimeters. So I offset this wood plane right here that I'm using as my straight edge by 28 millimeters from the outside of my draw line down there to get these edges perfectly straight, so that I could then use a router and the router bit to cut out the inner groove that the PC will actually rest in. I use this oscillating multi-tool to square off the corners. And this made it so that I didn't have to drop the whole bottom part of the cabinet out and to make this cut. Afterwards, I used my shop vac with a bristle brush and I vacuumed down everything to make sure that there were no dust particles on any of the electronics or in any of the fans. And I did a thorough clean of the entire inside of the cabinet. And now we're ready for a test fit. So that fits in there just perfect. There's a little bit of a gap here. I'm thinking about getting some weather stripping for like a door and putting it in there so that the PC is resting on that. When this is vibrating around, the PC isn't getting shook too bad. Here's the underview of the cabinet, and I mean, it gets all that room, all this space for airflow to get sucked in, and I think that's going to be key to keeping this nice and cool. Let's move on now, and I'll do some benchmark testing so you can see what it's like for at idle with the PC out of the cabinet, and then we'll do some benchmark testing for when it's in the cabinet, and we'll see if it's staying where it needs to be as far as cooling goes at idle, and then we'll put a load on it and we'll try doing some load testing inside and outside of the cabinet to see how this cooling really works, if it's about the same or if I need to make some improvements. In the Adrenaline software for AMD GPUs, you have the ability to log various parameters. I chose to log the GPU and the CPU temperature and the memory utilization to make sure that no background processes would kind of skew or throw the test in any way. For the control, I decided to run the PC hooked up to a single monitor with a mouse and a keyboard with no other peripherals or extra power draw on the power supply. And basically, this was just a standard PC test. And I told it to log the temperatures and the memory every 2 seconds over the course of an hour. The reason I did this is because I knew that the CPU temps would be higher for a 2 or 3 monitor setup, and I wanted to get a baseline to work off of. Then I noticed that when I did the control with the one monitor, and the GPU held solid right at 35C and the CPU held solid right at 32.5C. I then hooked up the PC outside of the case, but with every peripheral connected to include all 3 monitors, the 3 controllers, the audio puck, all the power to the fans, and everything else that I had been running on my old PC with the new cooling stuff added into it. The test parameters remained the same, and I noticed that the GPU was at 55C on average, and that the CPU was at 32C, and that for the background processes here, you can see that it held solid right at 3.62 all the way through the entire test. In almost every single test case that it pulled from, it was at 3.62. Then I decided it was time to get the PC fully mounted and get everything hooked up the way that I wanted it to be in the cabinet. Measured out the total distance around the PC, and it came out to be about 32 inches. So this will give me, these are 2 rubber cables here, and these are actually tarp straps. And if I hook these to an eyelet, they will give me a retaining strip that goes down and around the PC. I'm going to use these pronged T-nuts here to secure the eyelet down into the cabinet, and then I'm going to put a washer and a nut on the other side to wrench down the eyelet so it doesn't move. And then the tarp will hook to some eyelets, and then I got some window foam seal. This is just standard foam seal, and I'm going to put that down into the groove where the PC is going to sit, and this will act as a cushion to help absorb some of the shaking and bouncing around that's going to happen with the cabinet and the PC. I measured the tarp strap with the hook on, and it came out to be a little bit more than 32 inches, so I spaced it out a little bit more. And then I installed these lock nuts on the bottom of the cabinet, and then put the nut on the top part of this eyelet, and put a washer in between the nut and the eyelet. Screwed this down into this till it was flush, and then used the nut and torqued it down to the washer to get this kind of a setup. And it's adjustable up and down depending on how much tension you think you might need, but this isn't going anywhere. That really locks it in place. And now I'm going to do that to this side. This recessed hole in this cabinet has been a 2-week project to completely tear this down and put it back together again. And in that time, I decided to make a few other improvements to the cabinet. So one is I cut a grooved notch in here in the side because I have a lot of wires that go up to the back box now. And when I slide the TV in and out, the wires would get in the way. And basically what I did is I found the thickest wire I had that went up, measured that, and that's how deep I went into the wood. And I made it so that there's room for other things in the future if I need it. And then I printed a retaining strap here, bolted it in, and then up here the power distribution board is the retaining strap for up there. And then routed all the wires kind of up into the cabinet here. So there you can see the fan that pushes up through the back box. You have the 2 fans here and here that suck air between the glass and the TV display out. And then down in here, I went ahead and just completely remade this back panel. It's super thick, like the last panel was really thin. Put in the 2 new fans there, And then I made some cross braces here. This is to kind of help support the cabinet when it is in vertical mode when I'm in transportation. And then the only thing I really have left to do to this cabinet would be to put the support rails that go up and down to make it so that when it's vertical, it's not resting on any of the locking mechanisms or on the fans themselves to damage the cabinet. And then using some of that insulation foam down here to kind of help absorb vibration for the PC, I ended up putting a strip right here just to kind of help seal it. And then in the front side of the cabinet, you can see I moved the speaker back closer to the PC, and then you can see the two other fans right there. Here's those two cooling fans there. I went ahead and made this button right here the power button for the computer, so all I have to do is open the coin door, push that button, it powers the computer on. I also have put in, this is the Wi-Fi antenna here in the front. I added a USB port right there for, sorry it's a little filthy, I still gotta clean it, but I added a USB port there for an external hard drive so that Sid and I can share files with each other. And then I added down here at the very bottom this little port right here, which is where I'm going to hook up the mouse and keyboard for external right there. And this is like a nice, this is the same size as a button on the cabinet, and I'll have a link for that in the description if you want to have that. And then I made an extra hole here just in case I want to have an extra like reset button right here. If the computer screws up, I can add an extra reset button there in the future if I want to. But that is kind of the design here. I don't think I've ever shown you guys this over here, but that is the power switch to the main power, and that outlet is always on, so I can plug in a vacuum cleaner or a soldering iron. Even if the switch is off, if the wire or the cord is plugged into the wall, that outlet is hot, so I can just plug things in with the main power off to everything and it'll work, or plug in a drill or whatever else I need in the future. So that is how all that looks, all the changes that I made. I put the speaker grill covers on the bottom there to protect the subwoofers, and they are flush with that sidewall there, so it'll actually rest on the T-molding, not on the speaker grill. And then there's the underside of the hole over there where the PC will sit. Okay, so now the PC is completely mounted back there in the back. There it is. Everything is hooked up and running and idle. And I forgot to mention that the power distribution board for the fans is right here. I printed a little cradle for it, and it just kind of rests right there. And all the fans hook up to that. I think I've got like maybe 4 or 5 fans hooked up, 2 in the front, 3 in the back, and then the 2 smaller ones are hooked up to that power distribution board for the fans, and that is all controlled by the CPU inside the PC, so that if it starts getting warm in there, it'll say, hey, I need to, suck more airflow in, and it'll start sucking more air in. But I ended up also moving the chime array over here to the right. It still does not work because I don't have solenoids. I'm ready to start doing some testing. It's important to note that when I did both of these tests, I did it during a time of day at nighttime, and I made sure that the house temperature and the room temperature was at 72 so that didn't throw the numbers either. And when I had everything in the cabinet and everything up and running, I noticed immediately that the system memory was being utilized a little bit more than what it was for when it was outside the case. And I noticed that in the background, the PC was also downloading Windows updates, and it was downloading a few other software updates. So this kind of threw the test a little bit, but on average, I was getting 56C on the GPU, and I was getting 34C on the CPU. And, the average for the system utilization was 4.1, and you can see that all through the test, that system memory utilization fluctuated all over the place, from 4.7 down to, I think I saw like 3.8 or 3.9. Yeah, there's 3.89. It went back up a little bit and then back down a little bit, so it was kind of all over the place. So I was curious to see, you know, what the temperatures would be for averaging it out. And so let's take a look at the scorecard. So here's the controls, and you know, that gave us the baseline to work off of. And then outside the cabinet, that was the numbers for the GPU, the system memory, and the CPU temp. And then the inside idle temperatures were at 56, 4.1, and 34.31. That gave me a difference of about 1 degree or a little bit more than 1.5 degrees, but the system was being utilized, the system memory was being utilized almost a half a gig more than what it was for the outside test. So that 1 degree heat temperature difference might be because it was being utilized a little bit more. When you're running a game with an AMD GPU and you're using AMD CPUs, it's normal to see temperatures fluctuate up all the way almost into the 75 range, 75C. And then for the CPU, you know, anywhere in the 40s and the 50s, they do run hot. That's why I have the water cooling on the CPU. And the GPU, I would expect to get up to about 75C, and that's why we have all that airflow being pulled out. And so what I decided to do next, use the software that required the most features from the GPU, and that is the 22 version of Pinball FX. So I ran that and I played it for a while, and you know, going back and forth between different tables and everything else, and these are the numbers that I got. Okay, so to make this a fair test, I decided I was going to test all 3 pieces of software. I've got the FX 2022, Pinball X, and then Future Pinball right here. The same test parameters applied for these tests as it did before. So, you know, a minimum of an hour, pulling information every 2 seconds, and I added in an extra one for frames per second. I told each piece of software to go to the highest frames per setting that it could handle, and to really do a stress and a load test on this and get an idea of what the temperatures would be at those settings. So starting with Pinball FX 2022, we had an average GPU temp of 50, and the frames per second was 179.09, but it held in at 180 for most of the gameplay. The memory utilization was just under 9, and then the CPU temp was at 41. For Pinball X, we had an average of 54 for the GPU, about 60 frames per second. Memory utilization was 7.45, and then the CPU temp was at 41.61. For Future Pinball, we have 55.17, 59.85, 6.6, and then 46.61. Well, what does all that mean? Well, let's take a look. So what this tells me is that we never really went beyond what the idle temperature was for the GPU for any of these pieces of software, and that the CPU went up just a little bit, but you know, at 47 degrees for Future Pinball, I mean, we're obviously utilizing a lot more here in this software than we are, you know, in any of the other categories. But these temperature ranges, I'm not worried about them. Like, this is actually pretty average for, you know, playing a normal PC game for this setup. And you know, when you compare the idle, as soon as I left each one of these games, it went right back down to the idle temperature. So I think that the cooling solution that I have is actually fairly good, because the GPU only went up maybe 4 degrees, you know, Celsius. So it really wasn't that much. I mean, anything under, you know, 65 I would be happy with, honestly. And then for the CPU, anything under 50 I would be happy with. If this got up above 50, I'd probably want to consider, you know, changing some of the settings for the motherboard to make sure that, you know, when I reach a threshold of 50, that the fans kick on a little bit higher. But overall I'm pretty pleased with this. This turned out pretty well. And with that, we have now completely installed the PC. It's awesome. There's only one cord that comes down out of this cabinet right now. Aesthetically, all the exterior of the cabinet is now done. I think we're at a point where the finishing touches series is now coming to an end. We can now move on to planning what tables I want to have for Pincinnati. So if you learned something from this, please give me a like, subscribe, share this out with your friends. Thank you everyone for watching, and leave a comment below that tells me what pinball table you would like to see loaded onto this at Pincinnati. Thank you again for watching. I'll see you in the next one.